Okay, greetings. Sunday night. Hope you enjoyed your 3-day weekend. This right here is how we get the constant E. It's the limit as x approaches infinity. So of 1 plus 1 over x, and all that is raised to the x power. So things kind of counteract each other. As we plug in values for plug in values for x, this is going to keep getting bigger, and we're going to keep on putting in values that are bigger and bigger and bigger until they approach infinity. But also for the exponent. So as this denominator gets incredibly huge, this value approaches almost 0, so it's 1 plus a very small number. But yet, we're raising it to a very big exponent. Kind of counteracts each other and eventually levels off and approaches this value of e, which is approximately 2.78. I'm sorry. 2.718 ... and it goes on to infinity. Okay, here's just simple interest. Okay, what's a simple interest on a loan without putting too much thought into it? I have a principal amount. That's like the original amount. Let's say you're taking money out on a car loan or something. But just simple interest would be the principal amount times the rate in decimal form times the time period. Okay, you could have maybe $500 times 0.08, which would be 8%, times 2 years. Okay? All right? This rate here we adjust, though. If it's an annual rate and we compute our interest monthly, we'd have to divide that by 12 because it's 8% per year, but we do it every month. And this would be times 2 years times 12 months per year. So we're going to adapt, but right now this is 8% a year times 2 years. Here's how I can figure out the total amount of maybe, let's say, putting down a principal like $500 into a bank, getting a certain interest rate, and it depends on what we call how often the interest on our principal is compounded or computed. Okay? The more often it's computed, the better it is, because you start adding in interest and then computing interest off an increased amount. So we'll just figure this problem here. We're going to put $500 down, 9%, and going to be computed monthly. Okay, so $500, 9% monthly. Okay, so I'm going to put in $500 as my principal times 1, which is, the 1 means we're going to get the original amount back plus something. Okay, this in parentheses is a growth factor. We're going to multiply it times something more than 1, greater than 1. The rate is 9%, which is going to be 0.09 in decimal form. Okay? And then K, or in some formulas N, either K or N, refers to how often per year, because this 9% is an annual rate, a yearly rate. But we're going to figure out this interest or compound it monthly. So we divide this by 12. So we don't do 9% every month. It's 9% per year. So divide that 9% by 12. That's how much percent interest increase we increase our money by every month. And then we raise that to our time period, which will be K, 12 times how many years. And we're going to do this for a year. 1 year. Okay? So what's our money going to be after a year? All right? So this will basically be 500 times, you put this in your calculator, 1 plus all this what did I have here? Actually, we make this 5 years. My other thing, sorry. Let's make this 5 years. Okay? So I changed T to 5 years. So this is K is how often per year it's figured out. In this case, it's monthly. That's 12. And then we're going to do it for 5 years. So that's going to be 60 months. Okay? And if you put this in your calculator, you'll get $782.84. Okay? So that's what $500 in the bank can do for you over a couple of years if you're getting, and that's a high interest rate. You're not going to see that now in today's economy. All right, let's look at another problem where how long is it going to take, based on that formula of A equals P times 1 plus your rate over K to the KT, how long is it going to take for that $500 to become $3,000? okay? So we can go ahead and put in here $3,000 equals 500 times 1 plus 0.09 over 12, because it's compounded monthly still. All right? And then K is still 12, but we don't know what T is. So guess what? We'll end up doing a logarithm here. But if we divide both sides by 500, this ends up being 6 equals 1 plus 0.09 over 12 to this 12t power. Okay? All right? And what we get is, as I work this out, I'll move it over here, 6 equals basically 1.0075 to the 12t. And guess what we're going to do to solve for this exponent? Take the log of both sides, okay, and then this comes down. So we'll have the log of 6 equals 12t log of 1.0075. We'll divide both sides by this 1.0075. That cancels out. Okay, log of 6 divided by 1, the log of 1.0075. Okay, so this value is going to equal 12t. Okay, so I end up getting this log of 6 over this is 239.796. That's what the log of 6 over that is, equals 12t, and we divide by 12. T will equal about 19.98 years. Okay, so it's going to take about 20 years for $500 to become $3,000 just off of interest, without you putting any more money. Okay. Finally, one last problem. I'm at 7 minutes. Same type problem. Except this time, what are we going to figure out? We're going to figure out what the rate has to be. Same formula again. Your amount equals the principal times 1 plus the rate over K, or sometimes N, K times T. Okay? Now we need to figure out what the rate is. All right? For us to get, let's say, double our money. What was my problem here? 1 second, guys. Okay. This time, we're going to figure this out. Here we doubled our money, and we're going to go from $500 to $1,000. Okay, and we want to double our money. So, how long? What's our rate have to be? But what was the time period we want to double our money? And that was based on a 10-year. What's the rate have to be for us to double our money in 10 years? So we want to double our money in a 10-year time period. So T equals 10 in years. Yeah. Okay. Okay. So what's the rate going to be for me to double my money in 10 years? So I need to go from 500 to 1,000. So 1 plus rate over, and the other thing is it's going to be compounded quarterly. Quarterly. So that means every 3 months, or how many times per year? 4 times per year. So 4 equals K. All right? Sometimes they call that N. Okay? Doesn't really matter if it's K or N. Okay? So 1 over, so the rate will be some rate, and that's an annual rate, but we'll divide it by 4 because we're going to use it 4 times a year when we figure it out. And the net result will be close, will be near that original rate. Okay? All right, 2, and we're going to all raise that to 4, and we said 10 years. So what's the rate have to be for us to double our money in 10 years? So 4 times 10, that's 40, okay? So here I've got 1,000 equals 500 times 1 plus your rate over 4 to the 40th power. Okay, so that's what we're trying to figure out. What's the rate for us to double our money? So we took this 500, we put in 1,000. We want to find out the rate. We're compounding quarterly, so K is 4. It's 4 times a year. And K times T is 4 times 10. So 4 times a year for 10 years is 40. So this is what I'll do. We're going to divide by 500 again. Here. End up here with 2. Okay, equals 1 plus r over 4 to the 40th power. This will be kind of simplistic, but all I have to do to get rid of all this is I'm going to take the 40th root of both sides. Okay? When I take the 40th root of all that, guess what? This 40 goes, and I'm just left with 1 plus rate over 4. Okay? And that equals the 40th root of 2. Okay? And you can plug that in your calculator. Okay? So, all I have to do now is subtract 1 from both sides. So I'm going to have the 40th root of 2 minus 1 equals the rate over 4. And I'll multiply both sides by 4. Okay? And I will get my rate in decimal form. So 4 times the 40th root of 2 minus 1, okay, equals r. And that ends up in my calculator being 0.0699, and I'll times that by 100. I mean, we're going from decimal 2%, I go this way, and that, which is what times in by 100 does, and I get 6.99%. At 6.99%, that's a rate of 0.069, and we will double our money in 10 years, okay? How much time I have? I'm at 12 minutes. So we'll leave it at that, and we'll work a couple more problems. This will be for this video recap. We've talked about 3 things. Figuring out a rate. We ended up doing the 40th root of both sides. The other one was we had to take the log. We wanted to solve for what was the time period, okay? And there we had to take the log of both sides, solving for t. And then the other one is just plugging basically what's my the original problem is just, hey, figuring out what the amount's going to be at a certain principal initial amount with a certain rate and time period. And also, K refers to how often we compute it per year. How often do we compound our interest per year? Okay, we'll look forward to seeing you guys. This will be for probably Tuesday's lesson, but I'll put it up. All right, bye.